Hello everyone. So my name is Sandeep and today we have day 5 May Leetcode challenge. So today problem is very easy. Name is implement stack using queues. So basically we have to implement one stack with the help of queues. Okay. So before going into the problem, let's understand what is stack. Okay, so as you know, most of the people know stack is following property LIFO, or we can say philo. So LIFO means last in first out and philo means first in last out. So basically in stack we have a data structure where we add the values like 1, then 2, then 3, right? So last in first out means the element which is put in last is removed at first. So when I say pop, so this 3 is removed first, then this 2, then this one. So this is the stack. And if we talk about the queue, right, the property we have is FIFO, which is first in first out. Okay, it means let's suppose we are pushing elements like push 1, push 2, push 3, and when I say pop, so it will pop 1 first because this is the first element which we push. So this is the property of queue and this is the property of stack. Now we have to implement this stack, and this stack having push property, pop property, top property and empty property. Okay, now let's talk about the push. So in push, what we have to do, we simply have to add the elements, right? So we have to implement this stack. And how we can implement this tag? So basically I am going to implement this tag using queue. So what I do, I take two queues, q1 and another is q2. Okay, and this is empty in starting. Okay, this is also empty and this is also empty. Now what I did in push, let's suppose I have elements like 1, 2, 3 and 4. So when user said push 1, so what I do, I simply push 1 in it. When user say push 2, I simply push 2 in it. When user say push 3, I put like this, and push 4 is like this. So the push operation is very easy, and we can simply push it in our stack, in our queue, right? Now pop, this is the important thing we have to think about. So now talk about the pop. So in stack, the pop is like the element which is pushed last is removed first, right? But you know this is queue, and if I say q1 dot pop, so it will pop the 1 as an element. But this is not right, okay, because we have to implement the stack, we have to pop 4 from it. So what we do, we basically first of all what we do, we basically remove all these element, okay, until and unless this q1 contain only one element in it. What I mean by this, let's understand this. So what I do, I will check while the size, okay, of the q1 is not equal to 1. Until this condition, I simply pop from this and push into q2. Okay, so what is the size of q1? It is 4, so it is not equal to 1. Yes, so I, what I do, I pop, let me do here. Okay, so I pop 1 from here and push 1 here, right? Now the size is 3, which is not equal to 1, so pop 2, push 4. Now the size is 2, not equal to 1. Now pop 3, push 3. Now what is this size? It is equal to 1. In that case, this condition doesn't work, and what I do, I simply take a value as a variable and pop from it. So what it pops? It pops 4, okay, and this 4 is saved in this value. Great. After having this value, what I do, I simply push all these element within q1. So how it works, let me do it. Okay, So when I pop it, add it, pop it, add it, pop it, add it. Now this is a queue, so when I pop, it will pop 1. Why? Because it follows the FIFO property, right? And this is now empty. Great. This is now empty. And we have to return the value from it. And what value it contains? It contains the 4 as a value. And that is how we are going to write these two things. Top, in top what we have to do, we simply have to give the topmost element of the stack. Okay, so what we do in the top, we do the same process. Okay, we also get this value, but after getting this value we store it in some variable, and what we do, we simply push this value again to this q1 so that the value remains there. Okay, let me show you. So as you know, we have 1 2 3. So what I do, I simply do while this q1 size is not equal to 1, we have to pop. So 1 2 3 we have, right? So we have to pop 1 and store it. Now size is 2, now we have to pop 2. Now the size is 3. We come out of this while loop and we store the value in some variable. Now 3 is stored here. Okay. Now the 3 is stored here. After storing 3, what we do? This is a q2 queue, this is a q1 queue. What I do? I will push all these values again in this. Okay, and how it looks like, it looks like 1 and 2, right? And after that we also push this value in this queue, and now it becomes 1 2 3, and at the end we can return the value. So in that case, we put this value again in the q1 queue, and in this pop we don't push it. So that's how we basically do this top. And empty means we simply have to check the size of q1. If the size of q1 is equal to 0, it means true, the stack is empty, and if it is not equal to 0, it means false, the stack is not empty, right? So that is the code in order to implement the stack using two queues. Let's see the code, that is the logic. So we basically take two queues, right? And in order to push, we simply push in the q1 queue, and in the pop we first check if our stack is empty. If it is empty, we are not able to pop anything from it, and if it is not, we will check. If its size is not equal to 1, we basically pop from q1 and push in q2, and whatever the last element in it, we have to store it in value. In the pop you can see this value is not again pushed back. Okay, so we have to return the value. But in top what we do, same thing we do, this value is again push. Okay, you can see this value is again push in it, and then we return the value, and in this we basically check the size. If size is equal to 0, it means empty, otherwise it is not empty. Thank you.